Hello and welcome students. This is second lecture on indefinite integration. The previous lecture on indefinite integration, we had studied the important results which we obtained using the definition of integration. So in the second lecture of indefinite integration, we are going to see one very important theory, and after that we will use that theory to write certain more important results. We are not going to prove the theory. The proof of the theory will be done later. So let's begin with the important theory based on which we will have few more important results. So the theory goes as follows. It is found, students, that this theorem is misunderstood by many students. Reading the theorem, they think that they have understood it, but then actually most of the students misunderstand it. So it is very important for each one of us to be very attentive while I'm teaching you this theorem. So see, what does this theorem say? If integration of f of x dx, that is integration of function of x with respect to x, is g of x plus c, then integration of f of ax plus b dx, integration of f of ax plus b dx will be equal to g of ax plus b the whole divided by a plus c. Integration of f of x dx is g of x plus c. If this, it is very important for each one of us to understand what does theory say. The theory says if this, then this, then this. So what does it mean, students? The meaning of this theorem is very simple. You have a function of x, and when you are integrating this function of x with respect to x, you are getting g of x plus c. This is quite very simple, students. Whenever I integrate some function of x, I get some other function of x. For example, if I'm integrating cos of x, so integration of cos of x is sine of x plus c. So this becomes f of x and this becomes g of x. Integration of 1 upon x dx is equal to log of mod of x plus c. So this is f of x and here you have g of x. So the first line, which is after if, before then, if this then this, the first line says f of x integration with respect to x is g of x plus c. Okay, so like here cos is my f, sine is g, 1 upon reciprocal is f, log is g, log of x, g of x. So the theorem says that if integration of f of x dx is g of x, then integration of f of ax plus b. What has happened, students? It is required to be understood that you have replaced this x here You have replaced this x here. What have we done, students? It is important for us to understand that in f of x, this variable x has been replaced by ax plus b. That is, x has been replaced by x here has been replaced by ax plus b. What is ax plus b, dear students? It is linear algebraic expression. Linear algebraic expression. Okay. So when this happens, so integration of f of ax plus b dx will be g of ax plus b the whole divided by a. That is, f of x dx was g of x. So f of ax plus b dx will be g of ax plus b and the whole thing divided by a. That is, the coefficient of x was a, you divide the whole thing by a plus c. Okay, this is what it says. So if I want to apply this, if I want to apply this for some examples, how would it go? So let me tell you how would this go ahead. So students, here I will write, for example, let me write few examples for you. For example, first, integration of cos of x dx is equal to sine of x plus c. Therefore, now I apply this theorem. I apply this theorem here. So integration of cos of x dx is sine of x plus c. So integration of cos of ax plus b dx will be sine of ax plus b the whole upon a plus c. The whole upon a plus c. Let me write the second example. Integration of sine of x dx is equal to minus cos x plus c. Therefore, integration of sine of ax plus b dx is equal to minus cos of ax plus b the whole upon a plus c. Okay. So what is happening, students? See, this is my f of x. This is my g of x. So when I replace, now in f of x, this x, when I replace by linear algebraic expression ax plus b, rest all is same, my dear students. You can check cos of x, cos of ax plus b. I don't change the function. Since I'm not changing the function, that's the reason on the right, this is sine here. So here also you are getting sine. You're not changing the function. Only what you're doing is you're replacing this x variable by linear algebraic in x. Okay. So is the case here. Sine of ax plus b. So here also this x will be replaced by ax plus b and the whole thing is divided by linear, the coefficient of x. You have to divide by coefficient of x. Okay. So the third one is integral sec square x dx is equal to tan of x plus c, tan of x plus c. So therefore integral, see, I'm not changing the function. It is sec square, here also sec square. I'm only changing the variable. Sec square x it is. I write here ax plus b. Sec square ax plus b dx will be tan of ax plus b the whole upon a plus c. This is the third one. Then the fourth we had was sec x tan x dx, integration of sec of x tan of x dx. This function, integration of sec x tan x dx, is sec x plus c. Sec x plus c. Therefore, now see, once again, I will not change the function that I'm integrating. What was the function? It is sec of x tan of x. So here also it will be same. Only what I will do is, in the function, look at the variable part. The variable part is here, x. That x will be replaced by ax plus b. So integration of sec of ax plus b into tan of ax plus b dx is equal to sec of ax plus b the whole divided by a plus c. This is the integration of sec of ax plus b into tan of ax plus b. Okay. There are many more results which we will write now. Okay, now we see the fifth one. We see the fifth one. Integration of cosec x into cot x dx equals to minus cosec x plus c. So using the set theorem, I can write here cosec, therefore cosec ax plus b into cot ax plus b dx is minus cosec ax plus b, the whole thing divided by a plus c. Okay, students, I wish to tell you here something which as I said, earlier, that students commit mistake. Now, what do I mean by that? Suppose I write here cosec ax square plus b, then cot ax square plus b and dx. So what is happening? See, this is our main result, which is by definition. This one is our main result by definition. And we are applying the theorem on this result. As we are applying the theorem on this result. What do I mean? I mean that as we are having integration of cosec x cot x dx as this minus cosec x plus c. So when x is replaced by linear algebraic in x, that is x is replaced by ax plus b, the same effect we will have on the RHS. So minus cosec x will become minus cosec ax plus b, and then divide by the coefficient of x that you had here. The coefficient of x is a. So from this we are getting the next statement using the set theorem. My question is, what would happen if I replace x by ax square plus b? See, this time I am not replacing in the definition. This is by definition. Okay, this one which I enclosed in the rectangular box, this one is by definition. Now in the definition, when I'm replacing x by ax square plus b, this is very important. I'm not replacing it by linear algebraic in x. So will that give me, like here it gave me, when I replaced by ax plus b, it gave me minus cosec ax plus b upon a. So am I allowed to write minus cosec ax square? Am I allowed to write minus cosec ax square plus b the whole upon a plus c? The answer is big no. I am not allowed. No, I'm not allowed. Why I'm not allowed? Because that is not the theorem, my dear students. The theorem says x has to be replaced by ax plus b only. So remember, if anything other than ax plus b you have, you cannot apply that theorem. You cannot apply that theorem. So the sixth one we will have is integration of cosec square x dx. As you know, students, by definition you have written it as minus cot x plus c. So therefore integration of cosec square ax plus b dx. What will it be? It will be minus cot of ax plus b, the whole divided by a plus c. Then the seventh one. Seventh is, as you all know, students, integration of x raised to n dx is x raised to n plus 1 upon n plus 1 plus c. Therefore, integration of, see, x raised to n. So this, in this function, what I will do, I will replace x by ax plus b. Therefore, ax plus b raised to n dx. See, the function is same. Try to understand, dear students. The function is same function. There is no change in the function. Variable raised to constant, this one is, and variable raised to constant, this one is also. Yes, what I'm doing in this function, where I have x, I'm replacing x by linear algebraic in x. That's the change. That is the only change. So integration of ax plus b raised to n dx will be, corresponding change you do here, it will be ax plus b raised to n plus 1 upon n plus 1, and then you divide by the coefficient of x. The coefficient of x here you have is a, so you divide by a. Okay. Then we have okay, so next is eighth. Eighth is integration of a raised to x dx is a raised to x upon log a plus c. So therefore, integration of a raised to, see, I'm again writing the same function. What I'm doing is I'm replacing the variable by linear algebraic in x. But this time I'm writing the linear algebraic as px plus q. Px plus q. What I'm doing, I'm writing px plus q. I'm not writing ax plus b. See, till here I had been writing, in all these I replaced x by ax plus b, but here x I'm replacing this x by px plus q. Why I'm doing that? For the same reason, because otherwise the a will clash. If I write here ax plus b, then this will clash with a. So integration of a raised to x was a raised to x upon log a. So a raised to px plus q will be a raised to px plus q upon log of a into p. That is, you are dividing the whole thing by the coefficient of x, so that p, which is the coefficient of x, will come in the denominator plus c. Okay. Then you have ninth. Ninth is integration of e raised to x dx. E raised to x dx is e raised to x plus c. So integration of e raised to ax plus b dx. What am I doing? I'm replacing x by, here see, this is f of x, and in this x is replaced by, function isn't changed, function is same, only the variable x is replaced by linear algebraic in x, that is ax plus b. See, here I'm not writing px plus q. Here I'm not writing. Why? Because here I don't have any other a, but here I did so because the base was also a. So if I had written here ax plus b, that would have clashed with, that would make this confusing, which a where. Okay, that way. So e raised to ax plus b is e raised to ax plus b divided by a plus c. Okay. Integration of e raised to x is e raised to x plus c. So integration of e raised to ax plus b will be same, e raised to x plus b divided by a plus c. Okay. Very good. Then we have the 10th one. The 10th is integration of 1 upon x dx is log of mod of x plus c. So using the theorem, I will write 1 upon ax plus b dx. 1 upon ax plus b dx will be log of mod of ax plus b, the whole divide by a plus c. The whole divide by a plus c. Okay. Then the 11th one. The 11th is integration of 1 upon root x dx is 2 root x plus c. Therefore, 1 upon root of ax plus b dx will be 2 root ax plus b divided by a plus c. The 12th one, integration of 1 upon x squared dx is minus 1 upon x plus c. So this implies, therefore, okay, therefore, see, what am I doing, students? Am I going to change the function? No. So integration of 1 upon x square. See, I will not change the function. It is 1 upon x square. Here, the only thing I will do is I will write ax plus b square dx is minus 1 upon ax plus b and whole thing divided by a. So that is into a plus c. This is final into a plus c. 1 upon ax plus b the whole square dx is minus 1 upon ax plus b into a plus c. So we have written these results. These results we will refer to as list 2 of results. The list 1 results are the one that we wrote in the previous lecture. These are all list 2 results. So whenever I say list 2 results, I would mean all the results where I have replaced x by ax plus b. I have replaced x by ax plus b. So that is, x has been replaced by linear algebraic in x. Okay, students, there I missed 2 things here. Like here, integral with respect to x. So dx I missed, and here I missed plus c. So please write it. Now we will move to having done these 2 list of results. We are now equipped with enough results for solving few problems. So I shall take few functions for integration. So I begin with first exercise problems. First exercise, question number 1 has 5 questions, of which I will solve 2 questions. So to begin with, I take third problem. From first I take third problem. They say integrate the following with respect to x. So the function which they ask you to integrate, what you will do is you will put that between this sign, which is s and dx. You will put that between s and dx. So the function that they want you to integrate is 3 sec square x minus 4 over x plus 1 over x root x sorry 1 over x root x minus 7. Okay, minded students, in the textbook, in the exercise, they have not given, they have only given us the function. Okay, they have only given us this part, which I enclose in the red bracket, and they have asked you to integrate this with respect to x. So since I have to integrate the given function with respect to x, this thing, since I have to integrate with respect to x, what I do is I put that whole thing in the bracket and I write that with this sign, that is integral dx. So it becomes integration with respect to x. Like for derivative, what you do, you write d by dx. So you differentiate with respect to x by writing d by dx. You will write here this and dx. And between this sign and dx, whatever you write, it becomes, then it will be integrated with respect to x. This thing will be integrated with respect to x. Okay. So the next what I do is I write this as I. This becomes my integral I. Okay. So I write let I equals to this. This is my first step. Like in differentiations, we would write y equals to. So here every time you are integrating some function with respect to x, you would write I equals to. So now I write here separate integral. So I get here I equals to integral 3 sec square x dx. See, there are several terms here. Okay, see, this is 1, 2, 3, and 4. Between them, we have negative, positive, negative signs. Okay, so this is actually, it is like this one is f of x. Okay, this one is g of x. This is h of x. And here you have this as p of x. Okay, so when you are having sum and difference of, many functions and you have just a single integral sign, what would you do? You will write different integrals. Okay, you will distribute those integral sign for each one of the function with the corresponding sign. Okay, so there is a theorem for this, but the theorem I will be proving all the theorems. I'll be proving all the theorems in one video. One lecture I will prove all the theorems of integration, and in one lecture I will prove all the theorems of derivative. I mean this. See, there is a theorem, integral f of x plus g of x dx is equal to integral f of x dx plus integral g of x dx. Okay, so when you have sum of two functions and you are integrating, so it will be sum of their integrations. You will have to integrate each one of these separately. Likewise, if you have a difference between them, then you will have a difference here. So this is theorem. The theorems, as I said, I shall be proving all the theorems in one lecture, and that lecture will also be posted on YouTube. So here I have integration of 3 sec square x dx minus integration of 4 upon x dx plus integration of 1 upon x root x dx minus integration of 7 dx. So the next step I write is, see here, now 3 sec square x, this 3 will go out. So I have I equals to 3 is out, and I will get here integration of sec square x dx minus 4 is out. I get integration of 1 upon x dx plus, see, this particular function, this is not in a standard form, so I need to write this in a proper standard form so that I can apply a result. It is all about applying result. Minded students, you need to be writing in a form where you could apply the result of integration. Integration is all about application of result. That's it. Sec square x dx, when I see sec square x, I understand this is in the first list. Integration of sec square x dx is tan x plus c. When I see 1 upon x dx, I understand this is log of mod x plus c. But when I see this, I don't understand which result I apply. So I will have to write it in a proper form where I could apply some result. Okay, that is why when I taught you in the first, when I taught you in the first video, first lecture, I said that those results need to be written several times. you should write all the results in the first list and the second list 5 times. Minimum 5 times you should write. That will make a huge amount of difference. Okay, so here 1 upon x root x. I know root x is x raised to half, and here it is x. So this becomes x raised to 1. The power will be added, x raised to 3 by 2. Then it goes up because I have 1 upon. Okay, so 1 upon x raised to 3 by 2 will be, what will it be? It will be minus, it will be x raised to minus 3 by 2. So here you have x raised to minus 3 by 2 dx. And this is 7 is out, I have 1 dx. So now I shall apply all the results. 3 integration of sec square x is tan x, minus 4 integration of 1 upon x dx is log of mod x, and this is x raised to minus 3 by 2. So x raised to minus 3 by 2 plus 1 upon minus 3 by 2 plus 1 minus 7. Integration of 1 is x. And then I add constant of integration c. I add constant of integration c. Okay. But before I do that, I would like to mention something. See here. Normally what happens, you can raise a question that, sir, every single time I need to add a constant of integration. Like sec square x integration is tan x plus c. Very good. So since I have several integrals, I will write plus c1 here, tan x plus c1. Then integration of 1 upon x dx is log of mod x plus c2. Then integration of this I will write plus c3, and then 7x plus c4. So as such, I have several. See, each time I integrate, I need to write a constant of integration. Well said. That is true. Every time you integrate a function, you need to add a constant of integration. So here I should be writing c1 plus c2 plus c3 plus c4. But tell me, students, what do you think? c1 plus c2 plus c1 plus c2 plus c3 plus c4, isn't that again a constant? Sum of all constant is a constant. Yes, sir, that is again a constant. So what we do is, instead of adding so many constants with each one of the term, I would add a constant finally separately, and that will be c. So we don't have to add constant with each term. I will add constant once. So I write here plus c. So the answer is 3 tan x minus 4 log of mod x, okay, plus this is x raised to minus 3 by 2. So x raised to minus 1 by 2 upon minus 1 by 2 minus 7x plus c. Okay, so the final answer will be, it will be 3 tan x minus 4 log of mod x. Okay, this 2 will go up, so negative 2 upon root x, x raised to negative half, it will be down, x raised to positive half. So minus 2 upon root x minus 7x plus c. This is my final answer. I hope it's clear to you all, students. Okay, now I solve question number 1/5. Question number 1/5 is, let I equals to 3x cubed minus 2x plus 5, 3x cubed minus 2x plus 5 divide by x root x dx. Now see, students, here I need to give you some theorems on derivative integration. So as I said earlier, if you have integration of f of x plus g of x dx, then you will write integration f of x dx plus integration g of x dx. This is one. If you have integration of f of x minus g of x, then what will happen? You know. You will write separate integration of these two, and in between you will have negative sign. If you have integration of k multiplied to f of x dx, where k is a constant, so the only thing that you will have to follow is k is out. This k is out, and here you have integration of f of x dx. If you have, now the question is, if I have integration of f of x into g of x, students, check this. If you have integration of f of x into g of x dx, remember, when two functions are multiplied, we do have a theorem for this, but that will be used only after, say, 4 to 5 lectures. So right now, as of now, I'm saying that we are not going to apply any such rule. Any such rule. When we will apply, we will call this as integration by parts. This is integration by parts. So as of now, we will say there is no product rule. Okay? What am I saying? There is no product rule. So please follow this. We do not have any product rule in integration. We do have something like that which I showed you. We do have where we have product of two functions, but we do not term that as product rule. We call it as integration by parts. That we will do later. Okay? So what you have? No product rule. Very good. So what do you have to see for the, what if I have integration of f of x upon g of x and dx? If I have function of x divided by some other function of x, so do I have a rule here like we had in derivative? We had a rule d by dx of f of x upon g of x. Okay, you had a rule for u upon v. Okay, we did have a rule here in derivative, but in integration, remember students, no division rule. You do not have integration of f of x upon g of x. There is no such rule exists which you can call as quotient rule. No such rule. Okay? Yes. Now why do I find the need of this explanation? Why do I have to explain this? The reason was very simple, because you check here what you have. You have here in the numerator the problem that I am solving. The problem that I am solving here in the numerator, what you have function of x. In the denominator, you have function of x. Okay. So how do I do it? See, everybody check. It is always I go by the results that I have done. So list 1. How many results I have? I have 13 results in list 1. I ask myself, is there any result which is resembling this? The answer is no. I don't have any result which is resembling this. No such result. So what do? I will go for transformation. Remember students, the word transformation. Now what is meaning of transformation? You will understand in a while. Just observe what I am doing. See, the next step I write 3x cube upon x root x. See, I'm splitting the denominator, minus 2x upon x root x plus 5 upon x root x and dx. What I'm doing is I'm splitting the denominator, separately dividing the denominator. Now, why is this happening? Wait, because I have to integrate. So if I have to integrate, I need to write it into a form where I can apply the result. I was unable to apply the result at this stage. I was unable to apply the result at this stage. So what I'm doing, I am transforming, changing the form. To change the form is known as to transform. So what is happening? Transformation is taking place. Next step, see here. Now this is x, and here you have x cube. So you have 3x square upon root x. 1x will cancel, so x square upon root x. Now you know this root x in the denominator will be x raised to negative half in the numerator. Okay, then here this x and x cancels, so you have minus 2 upon root x, 2 upon root x, and here I have plus 5, and this is x root x. X root x is x into x raised to half, that is x raised to 1 plus half, that is x raised to 3 by 2. So it will be 5 into x raised to negative 3 by 2. 5 into x raised to negative 3 by 2 is what I get. Okay. So if you all are wondering that why am I not taking this root x up, because see students, I'm working for the results which I have. I do have integration of 1 upon root x dx. I'm telling you, you learn those results by writing them again and again. If you do not know what kind of results you have with you, you will definitely not be getting the ideas. It is very important you learn the results. So 2 upon root x, this root x, I know I can write this 2 out and I will get 1 upon root x. So 1 upon root x dx, I know it is 2 root x. That was the reason I did not take this x up and write raised to minus half. Whereas in the other cases, root x, I had to take it up because it was not only 1 upon root x. I did have some more x terms. Okay, so the next step, it will be I integration of, see here, 3 x raised to 2 into x raised to minus half. So it is x raised to 3 by 2. Okay, because 2 minus half is 3 by 2, minus 2 upon root x plus 5 into x raised to minus 3 by 2 dx. Okay. Next step, what I do is I will write integration separately for each one of these. I will write separate integral for each one of these. So integral 3 x raised to 3 by 2 dx minus here integral 2 upon root x dx plus integral 5 x raised to minus 3 by 2 dx. Okay, students, I'm writing each and every step. So if you want, you can skip few of those steps, no problem. You can always skip few of those. You know, I write all the steps because I have different aim. My aim is to make you learn perfect. So here you have next step as I equals to 3 is out, x raised to 3 by 2 dx minus 2 is out, 1 upon root x dx plus 5 is out, x raised to minus 3 by 2 dx. So now I integrate 3, x raised to 3 by 2 is, now you can all check, see here. Do I have result of this? Yes. Do I have result for this? Yes. Do I have result for this? Yes. Here how do I integrate? By x raised to n. Yes. Here how do I integrate? 1 upon root x. And here what do I apply result? Which result? How do I integrate? X raised to n. See. So what is happening? You all need to follow what is happening. See students, you had to integrate this, but you did not integrate all this while. What were you doing? You were transforming. See, this is known as the process of transforming. That is transformation. The given thing here, you changed into this. Now once it is transformed, it can be integrated. X raised to 3 by 2 plus 1 upon 3 by 2 plus 1 minus 2 into 2 root x. Integration of root 1 upon root x is 2 root x plus 5 x raised to minus 3 by 2 plus 1 upon minus 3 by 2 plus 1 plus c. So you have here, this is 5 by 2, this is 5 by 2. So 3 into x raised to 5 by 2 into 5 divide by 5 by 2. Okay, minus 4 root x plus 5 into x raised to negative half upon negative half plus c. So this gets you 6 upon 5 x raised to 5 by 2 minus 4 root x, and this is minus 10 upon root x plus c. This is final answer, students. This is final answer for question number 5. You can copy this, students. You can pause the video and copy this. Let's move ahead. Question number 2. In question number 2, it says evaluate. Now this time they are saying evaluate. The wording of the question has changed because the way they are putting the question has also changed. This time they are giving with the integral sign tan square x dx. Okay, what I have to do, I have to evaluate integral tan square x dx. So what I will do is I will write this as I. Let I equals to integral tan square x dx. Let I equals to integral tan square x dx. Now check this. So when I have to integrate, okay, that is to evaluate this is to integrate tan square x. Evaluate integral tan square x is to integrate tan square x. I have to integrate tan square x. So my question is very simple to myself, whether I have this particular function as a result in the list 1. List 1 means you understand those 13 results which we have done. The answer is no. We do not have integration of tan square x. Direct we do not have in the list. So if you think of trigonometric functions, what were those functions whose integration we had? We had integration of sin x dx. We had integration of cos x dx. We had integration of sec square x dx. We had integration of cosec square x dx. We had integration of cosec x into cot x dx. And we had integration of sec x into tan x dx. So students, as of now, this is second lecture. As of now, we have only 6 trigonometric functions whose integrations we know. Okay, so if I have this function, how do I integrate? Please do not apply results blindly. You know, some students, what they say tan x the square. Now this is x raised to n. So tan x raised to 2 plus 1 upon 2 plus 1. Oh my God, this is wrong. You can't do it. You cannot apply x raised to n here. You cannot apply. Why? Because these results are very specific. This is not done. Okay, let me explain this to you in detail here. Students, check this out. I'm writing something here. You all have to listen to it. Check this out. When I write integration of x raised to n dx equals to x raised to n plus 1 upon n plus 1 plus c, what is the function this side? The function here is variable raised to constant. Okay, now if I call this as variable raised to constant, could you please tell me which part is variable? It is this x is variable, and I am integrating with respect to x. You can check the function has variable x and you are integrating with respect to x. So now tell me, students, what right do I have if I'm writing, now see this function, if I'm writing this function as tan x the whole square dx, what right do I have to apply the same result here? Absolutely no right. I cannot apply variable raised to constant. Why? Because when I say variable raised to constant, see this is variable raised to constant. So here the variable is tan x. Check this. Is it matching? No. No. Remember students, you have no right to apply this result. It is not allowed. It is not allowed. You cannot write All these results are very specific. This is a very specific result. This is a very specific result. You cannot apply this result everywhere. Variable raised to constant is applied only when variable is x, or using the theorem which I taught in the beginning of the lecture, ax plus b, or x is replaced by ax plus b. That much is allowed. Nowhere else. I hope you all are following. In case if you do not follow, you can always write that in comment section. I will answer this. If you do not follow, you have a question, you can always write in the comment section. So students, I will have to go for transformation. I know the identity. I know the identity. 1 plus tan square x is equal to sec square x. So I can write tan square x as sec square x minus 1. I will write this as sec square x minus 1 dx. And then what I write separate integration. So integration of sec square x dx, integration of sec square x dx minus integration of 1 dx. So I equals to integration of sec square x is tan of x. Yes, integration of sec square x is tan x plus c, minus 1 dx is x, and I don't write separate constants for each one of them. I will write the constant at once, and see, this is what is the final answer. What is it? It is I equals to tan x minus x plus c, tan x minus x plus c. Very well done. Okay, students, let me take one more question here. It is cos 2. I take the fourth one now. The fourth one. Second and third are homework for you. I take the fourth one. I equals to sine 2x. I'm sorry, cos 2x. It is cos 2x over sine square x and dx. What do I do? See, I ask myself a question. When I look at this function, here, okay, what I have to integrate is cos 2x upon sine square x. Okay, so this becomes my integrand. This is known as integrand. What you have to integrate, what you are integrating is integrand. Okay, integrand. So this integrand, do I have this in list 1? The answer is no. So if I do not have in list 1, what I will do is I will ask myself, is there a possibility of list 2? The answer is no, because in list 2 what happens is every result you have in the list 1 is there in list 2, only the variable x is replaced by ax plus b. Such a function cos 2x upon sine square x I do not have. So what do I do here? Very simple. I will go for transformation. What does that mean? It simply means the given integrand is not in a form where you could apply a result. So you will have to change its form. You need to transform the given integrand. You need to write it into such a form where the result is applicable. So here you have to check. Here you get the check of your trigonometry or mathematical knowledge. See here, manipulation, cos 2x, I will write cos square x minus sine square x. What is cos 2x? It is cos square x minus sine square x. Or you could have even written 1 minus 2 sine square x. Even that was okay. We can even do that. Both of these will work. I will write for cos 2x, I know the formula 1 minus 2 sine square x, and denominator is sine square x. Then what I will do is I will split the denominator. That is, I will write I will separately divide by sine square x. So I get 1 upon sine square x. I will get 1 upon sine square x minus 2 sine square x upon sine square x. So I have only 2 and dx. Then this is 1 upon sine square x is cosec square x. So I have integration of cosec square x minus 2 dx. You can check, see what have I done. Integration of cosec square. Do I have integration of cosec square? Yes, very much. We have integration of cosec square x minus 2 dx. You know what will happen next? That 2 is a constant. That 2 will go out. That 2 will go out. So you have therefore I equals to, you have I equals to integration of cosec square x dx is minus cot x plus c, and this 2 is out. So 2 is out, integration of 1 dx is x. So you have here minus 2x plus c. This is final answer. This is final answer. Okay, please. You can pause the video and repeat the solution once again for your better understanding. So let's see one more question. Let I equals to integral sine x upon 1 plus sine x. So students, once again, you do not have a direct result which you can apply here. So what you will do is you will transform. Now I tell you the method. I will just hint out the method. The rest you have to do. You will multiply 1 minus sine x in numerator and denominator. What I said, you will multiply 1 minus sine x in numerator and denominator. Yes. So this will become sine x upon 1 plus sine x. And then when you multiply 1 minus sine x in numerator and denominator, 1 minus sine x in numerator, 1 minus sine x in denominator, the rest will happen automatically. See, this will get you 1 square minus sine square x. So denominator will be cos square x. This sine x will multiply both the terms. And then you split that cos square x, you will get the answer. Okay. I give you a hint for one more question. See, it is integral tan of x upon sec of x plus tan of x. Okay. So now here there are two methods for this. There are two methods for this. See, the first method for solving this is, once again students, I do not have a direct result which I can apply for this integrand. No, I don't have a direct result. So what I will do, I will try to transform this. So the first one that I will do is, see, I will multiply sec x minus tan x up and down. So sec x upon sec x plus tan x I multiply sec x minus tan x up and down. Sec x minus tan x and sec x minus tan x. This is what I do. Now when I do this, students, what will happen? Very simple. Listen, the denominator will become sec square x minus tan square x. It is a plus b into a minus b. So I will get sec square x minus tan square x. And you know, students, sec square theta minus tan square theta is 1. So the next step, you will not get any x in denominator. You will get 1 in the denominator. So here you have only numerator you are left with. And then in numerator, what you have sec into sec and sec into tan. So you have sec square x minus sec x tan x, which is over. Now see, integration of sec square x, you know, integration of sec x tan x, you know. You will write separate integration of this, and these two functions, both of these functions, I have the result. I have the result for both of these functions. Integration of sec square x is tan x, and integration of sec x tan x is sec x. So the final answer is tan x minus sec x plus c. This is first method. I said one more method I have. Yes, I do have one more method. The second method is I change everything in sine and cos. So like tan x, I write sine upon cos. Okay. Then here I write 1 upon cos. and here I write sine upon cos. So what will happen? You check what happens next. The denominator, you get 1 plus sine upon cos, cos cancel, sine x upon 1 plus sine. Once again you get this. So when you write it this way, it becomes exactly same as question number 6. I have explained you both the methods. I have explained you. Okay, so for now we end here, students. I shall be writing few more problems for you in the homework section. uh, you can solve those problems. Thank you. The rest we will see in lecture number 3. Yeah, hello students. I would like to rectify some mistakes which I committed. It was, the method would not change, but there is a mistake which I committed. This is tan x here and I wrote sec x. So nothing much. You will simply write here tan x. So this would remain tan x only. So still the method is same, you know, that hardly changes anything. So tan x when multiply sec x, okay. So I will get sec x tan x. When tan x multiplies sec x, it becomes sec x tan x. Sec x tan x it becomes, and this is minus tan x into tan x is tan square x, and dx here. So definitely that would change the next step. That would change the next step. How would it change the next step? The next step would be, see here, you will, the denominator is 1. The denominator is 1 and you integrate only the numerator. So you will have integration of sec x into tan x dx minus integration of tan square x. Remember students, the denominator is 1. Sec square x minus tan square x is 1. So in the next step, you have only to integrate sec x tan x minus tan square x. So you will write integration of sec x tan x and you will write integration of tan square x. Now, so far as sec x tan x is concerned, you know the integration of sec x tan x as sec x. But tan square x, you cannot integrate directly. Tan square x, you cannot integrate directly. Why? Because in the list, we do not have this one. Tan square x integration, we do not have. So what we have, we have integration of sec square x. So what I will do? Yes, I will transform this. I will transform this into sec square x minus 1 first. I will write it. So see here, the next step I get here sec x tan x. I have here sec x into tan x dx minus integration of sec square x minus 1 dx. What is tan square x equal to? As I know the identity, 1 plus tan square theta is sec square theta. So tan square theta is sec square theta minus 1. Here it is x. So sec square x minus 1. And then next step, you all know what it will be. You have integration of sec x tan x, and then you have integration of sec square x. You know the integration of 1 also. Integration of 1 is x. Okay. So I'm extremely sorry. I missed that. I wrote it tan x. I wrote it sec x here, but it was tan x. Okay. But the second method is as it is. You can just pause the video and copy it, and you can complete the rest. Thank you. We will see the rest of the problems in next video. That is lecture number 3. Bye for now. Thank you.